All right, MAP4C, day 26. The lesson is 3.4, titled Analyzing Data with TI83s. And so this is going to be kind of weird for you to follow along today's lesson once we get into it, because it's nice to have a graphing calculator available. And hopefully in class we talked about how you can get one on your computer, maybe not for your iPods or whatever, but on your computer you can get a copy of the graphing calculator, hopefully. But we'll get into it. The goal for the 3-minute review is to draw a line of best fit to represent a scatter plot and use a line of best fit to make predictions. This is what we've been doing the last couple of days. Asked us to draw a scatter plot for this data, and I cheated a little bit here because it takes a little while to do a scatter plot, and we wanted to move on with this. And who knows what the title would be? Scores, maybe student scores. Who knows on what? Maybe instructional hours makes me think of driver's ed, maybe. So who knows? If we did that, identify or circle the outlier of the data. Now, which one's the outlier? That one right there, right? And it's way easier on the graph to see that. That is this person right here. This person right there studied for 20 hours or had 20 hours of instruction and still got a score of 45 on whatever test it was. So they're the outlier. Done. Draw a line of best fit that would include the outlier and another line of best fit that skips the outlier. Okay. So including the outlier, let's change our color here. Including the outlier, the loop would, the tight loop, this, and maybe you can do this without the loop. I don't know. This something like that, and then your line of best fit is kind of cut that in half. Right, so maybe something kind of like that. It's not, not going to be exact, but I'm going to change the color so it matches the loop. Pretty close. Change the color again here so I can get one for another loop for the X outlier. That's a little bit easier line of best fit to draw, isn't it? And I'm going to actually extend that one for a reason we'll see later. That looks pretty good. We got 2 below, 1 above, and it goes through 2. That's looks pretty good. Fine. Oh, I'm going to change that to color. Great. Green. Look at all the greens. There, green. I think the outlier should be included in this relationship, and anything you said here that you backed it up with would be yes or no. But you just have to talk intelligently. I think you'd say, they're so far away from the rest of a really nice trend that something must be going on with this person. Maybe they're just a really, really terrible driver, and no matter how much instruction they got, they're not going to do well on their test. And so you want to exclude them. You could say, well, there's some people that's the case, so they should be included. So this is opinion. I'm not going to. No. ... Calculate the equation for the line of best fit that's most appropriate in your opinion. So I'm going to do the green. I'm going to go y equals mx plus b. And we're going to pick 2 points to find the slope. And because I don't have any breaks, I can actually read my y-intercept straight from the graph. And it looks like it's right there, right? There's my y-intercept, and it looks like 65. But if we couldn't read it, or you put a break in your graph, we could calculate that, Stu. And we covered that in previous videos. Just look back a couple of videos. It's all good. The slope is y2 minus y1 over x2 minus x1. We just got to find a couple points that are on or close to on this line here. There's one that looks nice. See that? How that goes right through the corner And I like picking nice points that are easy to read, but this one goes straight through the corner of my graph paper, and that's 17 and looks like 90, 17 and 90. Where's another one that goes, this point here looks like it's right on, you know, the line's right on it. And it's actually a point from my table, so I can know exactly what that one is. What is it? That's 6. And which one was 6? 6 and 75. And those are the 2 points that I'm going to use. Remember, x1, y1, this is x2, y2, and then I can do my slope calculation here. Y's are on top. Subtract 75 over 17, subtract 6, and I get 15 over 11, which is about, I'm going to get a decimal answer here. 15 divided by 11 is about 1.36, and that's my slope. So my line of best fit is 1.36x plus 65, and it says, and this is the idea of predicting. Predict how many hours of instruction you would need to get a perfect score of 100. And we could just do it in the graph, right? We could just go, where's 100? Bounce off whichever line of best fit you think smart, and then go down, right? So if I use my graph, kind of goes off the graph, but maybe about 24. So I'm going to say from the graph, study for 24 hours, or hours of instruction, 400. That's from the graph, but of course, we don't like the graph. We like doing it using some math, right? Graph is math, but some algebra. We have our equation, and we want to know when the mark, the y value, the dependent variable, is 100. Subtract 65 from both sides, 35, 1.36x, divide both sides by 1.36, 6, and then I get about 26.5 hours, rounded. For a mark of 100. Good. This is kind of weird, because I know you're probably just following along and using the same points as, but if we use 2 different points, or even if we had, you know, our line of best fit here had slightly different curve, that's still a pretty good line of best fit, but we wouldn't have used that point. It would have had a slightly different slope. In fact, every single person in the class could have got a different line of best fit, right? This was the equation of our line of best fit. This seems very, very strange, even if you just think about the word, or the words, line of best fit. If everyone's got a different one, how could it be the best? And that's kind of troubling, and today we deal with it. So in the lesson, and hopefully you got that, the rest of that was okay. And in the lesson is dealing with this idea. Use technology to generate a line of best fit and make predictions. And this is exactly what I said. The problem with our line of best fit is that was based on a lot of guesswork. 20 different people might get 20 different lines of best fit, and this isn't very best, right? There should be one answer that represents the line of best fit. You know, ding, 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 the line of best fit. And we're going to find it today. And we're going to use the calculators, okay? So in general, the steps are, and I'm going to see if I can, you know, go back and forth from the calculator to my note to explain, you know, what's where. Here's my calculator. It's kind of in the way here. I'm going to get rid of this. When you turn it on, the calculator, it could be in all sorts of different modes. And right now mine's pretty clear, but you could have a graph on there, or you could have, you know, you could be anything on there, but generally you can follow these steps and it's good. Since we're doing statistics, we hit stat, and then we hit edit or select one, and then we're into our lists. And notice the picture has nothing in the list. We might have to clear it off. See, I've got a bunch of crud from somebody, whoever was the last one to use it, left it over. To clear it out, we go into I use the cursor keys here. You see the cursor keys. Go up into L1, press clear, and then enter. I'll do that again over here. Go up into the top, hit clear, no, not enter, hit clear, then enter, and then it's all gone. And now it says to enter the data. So I'm going to enter my data, including my outlier. So I go 10, no, 10, please, thank you, 10, there. Should have saved some time and put this in earlier. It's probably pretty boring watching me play with the calculator. But I can't do anything unless the data's in there. So 12, 12. The rest of the numbers are okay, I hope. I may have slipped on one, doesn't really matter. Okay. 12, and now I'm going to put in the other numbers. I'll go over to list 2, and I'm going to put in all the scores. 78, 85, 85. Why is that not working? Well, there we go. 85, 96. And they should line up. You should have equal lines of data there to see. I'm going to check my time here. I might have to split this into a second video. How are we doing? 12 minutes. Can I finish quickly here? I think I'm going to stop there and go into a part 2. Part 2 won't be this long, but I think